Welcome. This video is going to go through the Chapter 2 quiz solutions, looking at both multiple choice, how to answer those in under 2 minutes without calculators, and then the free response. So question number 1 says, which statement about the number of protons, electrons, and neutrons in an atom is always correct? So by definition, an atom has no charge, so the protons and electrons have to be equal. But any atom can have isotopes where the neutrons vary. So the number of neutrons minus the number of electrons is 0. Maybe, maybe not. Number of protons plus the number of neutrons equals the number of electrons. Definitely not. Number of protons equals the number of electrons. Ding, 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 we have a winner. And the number of neutrons equals the number of protons. That can be true, but it isn't always true. Number 2 then asked, in the emission spectrum of hydrogen, which electron transition would produce a line in the visible region? What you have to remember about hydrogen is it drops to, let me get my scroller here, it drops to energy level 1. It can drop from an upper level to energy level 2, or it can drop to energy level 3. And we know there's a visible spectrum, a UV spectrum, and an infrared spectrum. Well, this has to be UV with the most energy. Visible is the middle one, and infrared's the least energy. So which would produce a line in the visible region? That would have to go to N2. You pretty quickly can eliminate A and D because they're both dropping to N1. So it was really between B and C, but B would be the correct answer. The medium amount of energy is visible light. Looking at number 3, they want to know which of the following is an isotope of 2412 magnesium. Well, remember, what makes magnesium magnesium is this 12. So there is no such thing as magnesium-13 because that's actually aluminum. So then which one's an isotope? Well, the 2 plus is an ion, whereas a different mass or different number of neutrons makes it an isotope. Number 4, closely related, which statement about the isotopes of an element is correct? They have the same mass number. No, that's what makes them an isotope is they have a different mass number, a different number of neutrons. They have a different atomic number? No, then they wouldn't be the same element. They have the same chemical properties? Yes. The physical properties can vary like density and mass, but the chemical properties are going to be the same. Or D, they're located in different places in the periodic table. No, magnesium and other elements get one place on the periodic table. It's the isotopes are accounted for in the average atomic mass. Number 6 wants to know the correct sequence for the processes occurring in a mass spectrometer. A mass spectrometer is all about mass because it's supposed to separate isotopes. Your book doesn't talk much about mass spectrometers, and allegedly you're not going to have to know a lot about this for the test other than it separates isotopes. And it separates them according to mass and according to charge. So the basic steps is that it vaporizes it or changes it into a gas, because once it's in a gas, it's easier to ionize it. And they do that by bombarding it with electrons. And so you create some positive and some negative ions. Some of the atoms, depending upon what you have, which element you have, they may want to gain those electrons or it may bump electrons off. And then you accelerate your ion. And when you accelerate it, then you're going to send it around a curve, and that's where the deflection comes in. Heavier ions are going to have a harder time negotiating the corner. If you have it set up so the spectrometer looks something like this, and here's the curve, and you've got these charged plates, if you have positive and negative plates, if your ions happen to be negative, if they get pulled toward the positive, that lets you know something about their charge. If they're heavy, they're going to tend to go this way. And then there's another step they don't include here called detection. They look at how many crash into this same spot, and that lets you know how many of these heavy ones couldn't make the corner. The lighter ones make the corner, so they record how many make it all the way around the curve. That gives you an idea of the abundance of that isotope. So that's kind of the basics of a mass spectrometer. So A would be the correct order of steps. Number 7 says a sample of element X contains 69% 63X, 31% 65X. So initially it looks like you have to do some calculating, and this isn't the nicest math. But if you look a little closer, you know your average has to be between 63 and 65. Well, that eliminates 69. You don't have all one isotope, so it can't be exactly 63 or exactly 65. So really, B is your only choice. They simply want to know if you realize what a weighted average is. Number 8 then, if I get my scroller here, wants to know which species has 54 electrons and 52 protons. Well, 52 protons is what determines the element. So I look it up and I see that this is tellurium. It doesn't have 52 electrons. It's got 2 extra electrons, so it has picked up a -2 charge. So the only one that fits this is 12852 Te -2. Number 9 wants to know which species have the same number of electrons. Well, sulfur is element number 16, and if it's got a -2 charge, it's picked up 2 more electrons for a total of 18. Chlorine is element 17, it's picked up 1 electron, also for a total of 18. And neon is element number 10, noble gas, not going to likely pick up a charge, so it's got 10 electrons. So looking at this, 1 and 2 are my only species with the same number of electrons. Number 10 wants to know what's the electron arrangement of an Mg2+ ion. Well, remember, Mg, magnesium, is element number 12. So normally its arrangement would be 2, 8, and then 2 in that 3s orbital. But because it's picked up a +2 charge, these 2 electrons have been lost, and B would be the correct electron arrangement for an Mg2+ ion. Number 11, really what I wanted you to be able to do was part A on here, define the term relative atomic mass. Relative is really the key word here. Atomic masses were determined by comparing them to carbon-12. So when you define relative atomic mass, you have to mention it's the atomic mass or the average atomic mass of all the isotopes relative or compared to carbon-12. And that's what will get you your 1 mark. Mass spectrometer, draw a simple annotated one. If you were asked to do this, basically what you need is something that looks like this. You indicate this is a charged plate, or you could just put a plus and a minus, one on each side. But then you have to be able to tell the steps that you, you vaporize it, then you ionize it, then you accelerate it, and then this deflects it. And if you want to, you can include the last step of detection. Number 12, identify a radioactive isotope of carbon and state one of its uses. The 2 big ones are carbon-14 and carbon-12, or carbon-11, I'm sorry. Carbon-14's most common use is dating old things. See how much carbon-14 is still in there and how much is broken down. And they both can be used in medicine as what we call medical tracers. They allow them to follow the carbon through your body and see where it's being used or where it's being absorbed. Number 13, you were supposed to draw and label an energy level diagram for the hydrogen atom. In your diagram, show how the series of lines in ultraviolet and visible regions of its emission spectrum are produced. So ultraviolet and visible, clearly labeling each series. So for 4 marks, what they wanted to see, what IB wanted to see, is that you label these energy levels, that you realize the greatest distance is between N2 and N1, slightly less difference between levels 2 and 3, even less distance between 3 and 4, 4 and 5, 5 and 6. So that was worth 1 mark to have labeled your energy levels. It was worth another mark to show what they call this convergence here, to have your diagram set up right. And then you got a mark for showing that ultraviolet is going to go back to level 1, and you had to show at least 3 emission lines for ultraviolet, and you should include the arrow showing that it's being emitted, or the excited electrons dropping down, as opposed to absorbing the energy and moving from the ground state out. And then visible, you had to show, goes to just the second level. And again, you needed at least 3 emissions shown with that. So that was your 3rd and 4th mark. Okay, I apologize. I've already written on here. That's because I lost my recording, so I'm just going to try and interpret my writing for you. Continuous versus a line spectrum. I describe it as a rainbow and a colored barcode, but that's really not quite scientific enough for IB. So what continuous means is that the colors continue into each other, or all the frequencies are seen in that spectrum. But a line spectrum is also called a discontinuous spectrum because some of the frequencies or colors aren't present. Okay, they either weren't emitted or they were absorbed. And then C, the thinning of the ozone layer increases the amount of UVB. Why is that more dangerous? Well, what you're supposed to notice is it's the shorter wavelength, so that was worth 1 mark. And then that means it's higher energy and higher frequency. And then for the 3rd mark, you were supposed to realize that this is what damages cells or causes cancer, is the higher energy frequency hitting our skin cells.